collect retinas from animals for the competitions that they have running on. Signature uses variables linked to how an individual signs their name and is a behavioral biometric. I can change my signature. So again, some underlying variables may be the same. Many people don't like it. They say it's a fairly weak form of biometrics. And each semester in class, I try and have people forge my signature. And I collect 91 variables of that signature. So if you get it graphically right, you're not going to get it dynamically right. You might not get my speed or my number of pen up, pen downs. And we've all known someone that's forged someone's signature sometime. And it really depends on the level of knowledge. How many people here forged their... How many people here know someone, because it's on tape, that could have allegedly forged their parents' signatures sometime during high school or grade school or something else like that? And I'm going to stick my hand up because I did it a couple of times. What did you use? You used your graphic, or you probably traced it, right? Or you kind of went over. As long as it looked the same, that's all that matters, right? If you do it electronically, you could look the same. Someone could trace it, but you're not going to get their speed or force or pressure typically. So signature verification can be pretty good. Drawbacks to that: different digitizers. You're not used to it. How many people signed on the UPS brick? Yes, your signature doesn't look like anything at all, does it? It doesn't look like yours at all. So the digitizers there sometimes are a problem. And voice, it's a combination of physiological and behavioral. There's obviously some issues with voice. If you've got naturally speaking by Dragon software, sometimes it doesn't pick everything up. It may be problematic. We've been testing the differences between landlines and cell phones. Performance drops dramatically. I shouldn't say drops dramatically. The curve drops exactly down. It's kind of interesting between cell phones and landlines. And again, depending on service carrier or your phone, different makes of microphones in different phones. Sometimes the cheapest phones are sometimes better at this. And fusion. When biometrics, we want to combine them, multimodal fusion occurs. This is a great area of research that we're looking at working with people. Right now we're in the process of collecting data. There's not a database out there that has everyone's biometric because there's a lot of issues relating to what do we do with that data. So if I'm going to collect some fingerprint data, and I collect your hand, and signature, and face, and iris, and voice, what do I do with them, and how do I look after them? So, because that's a lot of information you're giving me. But we actually need those databases in order to run fusion algorithms. And the idea here is that if it's in an environment where my hand isn't good enough, for example, this hand here is not good enough, we might be able to merge it with skin and weight the skin higher for me than the geometry for you. If it's iris, I might be able to take your face at the same time, seeing as I'm using a camera. So there are plenty of ways of doing that. All right, are there any questions? We have until 5:20. Okay. No questions? Yeah.
I mean, my hands are different. I mean, I can see the different size of the fingers, but that would not pick up as a difference in a hand scan?
Typically not. What we would do is you would align your fingers in the reader, and then for your left hand, we would turn your hand upside down, and it will create the same image. The only thing you'd have to take your rings off because that would obscure the camera light. But typically they are the same. You'd have to reduce the threshold slightly because it's very hard. In fact, it's not very easy to keep that hand flat. That hand is flat on the platen. And this hand, because your hand is not flat on the top of your hand, it's kind of hard. So you would need to reduce the level. But you could still gain access with your hand upside down in a hand geometry environment. It's pretty cool stuff. Any other questions? All right, so let's take a look at enrollment first. Enrollment is incredibly important. If you don't do this right, the rest of the day is really upset because you won't be able to do performance measurements on them. So you really need to know what you want when you enroll a person because you only get them once because it's really hard to get people to come back once once you haven't collected the right data. So I got to figure out what sample I want from you at the very beginning. I want to figure out whether I need to know who you are or I just need to have your biometric from you. So for example, if you need to get into this room and you're registered, what information do I need from you? Do I need to know your name, or do I just need to know that you're in this class and you dump your hand at the door and I grab that information from you. All right? I need to be able to figure out what my population is in order to make sure that everyone has all the biometrics that I'm going to be taking. If, for example, I have a hand geometry reader, I need to make sure on the height of the hand geometry. If I got iris, I got to make the position of the camera. And of course, we come in various sizes and heights, so that's an issue as well. I need to kind of get an idea of that. For example, if I'm going to put hand geometry in at a border control point, I need to deal with everybody. So typically, it's at this height, and people look down onto it, and that's an easier way of doing it, as opposed to having it at the 6-foot height where no one can get a hold of it unless you're 6 foot. We need to figure out how to create the template. You need to figure out how you're going to store the template, and you're going to have to figure out how you're going to protect that template to make sure that people don't grab that template and either delete it or use it for their own use. And you've got to figure out how many samples and the quality of that, because you really only get one time at this enrollment deal. And then verification is relatively simple. This could be /identification. We just grab the sample, we make sure that all the features are out, and we do this quality check. I'm just going to show you an example here. This is an example here of a poor quality fingerprint. So it's a relatively, you can see that's an 81-year-old fingerprint. And it's very hard indeed to grab those images. In fact, there aren't many databases with 81-year-old fingerprints in them in the first place. I think Purdue is one of the only ones that collects them. We have them all the way up to 101, and we've got them over a period of time. And this is very important for those people that are developing algorithms, because if you're dealing with algorithms and you're training your algorithm on the best quality fingerprints you can get, then when this one rolls along, you're going to be in a lot of problems. In fact, McDonald's stopped a trial of fingerprinting at their Fresno branch. They had a trial where you could put your fingerprint down and get your coffee, and that fingerprint was tied to your ATM card. You didn't have to carry anything with you. You just walked in there, dumped your fingerprint on the sensor, and you get your coffee. And one day, someone who was elderly could not go ahead and get their coffee, and they withdrew it immediately because people would say, oh, it doesn't work for me, and that's really not the focus of McDonald's customer service. So they removed it. And so there are issues associated with that. US Visit, for example, does not fingerprint elderly when you come into the country. Identification, you need to make sure the transaction is processed by the system, and you need to figure out these candidate lists as well. I mean, if you go to an airport and the performance pulls off 1 in every 10,000 individuals, that's still a lot for a throughput on an airport. It's going to slow things down. So you need to figure out how you're going to segment your audience. You don't want to search the entire planet for 300 people jumping on one plane. So you need to take that database and search only those 300 people. So when you board, the errors are likely to be a lot less. All right? And some of the issues with the ACLU and other people is not necessarily on the need to do it. It's the error rates of how, when you're pulling them off, I'm being subjected to double screening because the algorithm is not yet good enough. So those are issues. You can solve some of these issues by being clever and reducing your search database. So if you know who's going to jump on the plane, put them in the database of the day. Don't put me in there if I'm not going to travel till next Wednesday. All right? So you might need to be a little smarter on that. And again, quality checks are very important. And this all goes back to the enrollment. Make sure you have enrollment images that are the same as the verification images. If you've got a really sunny environment and you're taking photographs of people at the check-in, for example, check-ins are normally bright and airy. Security area is normally dark. Those are going to be 2 different illumination levels. That's going to impact face recognition for sure. Okay, so those are some of the issues with performance testing. I'm just going to show you some graphs here. That's a graph that measures performance. It's a detection error trade-off curve. And these different biometrics, this comes out of the NPL study done about 5 or 6 years ago now. Each one of these is a different biometric. And this comes back to my question on which one is the best one. It depends on the error rates that you're looking for.